Good evening, Honors Algebra. This is your flipped lesson for the weekend of December 2nd. Getting close to Christmas break. We got a lot more to do. We're actually going to combine two lessons in one here today because I think you guys are ready to handle it. Both lessons are pretty simple. I'm going to start with the absolute value because I'm telling you the truth. I'm recording this Friday at about 4:15 and my brain is fried. So I'm going to try to get the math flowing again here. It's been a long week. Good week, but a long one. Let's talk about absolute value. Absolute value has a very special definition. The absolute value, the definition is the distance from 0 on a number line. The distance from 0 on a number line. So, if I ask you for the absolute value of 5, just like that, you're going to think of a number line in your head. You may not have to do all this work, but you're going to think of a number line and think how many spaces is 5 from 0? Well, it's 5. Therefore, the absolute value of 5 is 5. Why? Because 5 is 5 spaces from 0 on a number line. The definition of absolute value is the distance from 0 on a number line. I guarantee you, we go to any university and we talk to some algebra or calculus students, and many of them, will give you the wrong definition of absolute value. In fact, when I help Mr. Morgan interview math teachers for the building, I always ask that question because it's a misunderstood concept and people do it wrong. So the distance from 0 on a number line. What would the absolute value of -3 equal? Well, let me see. There's my friendly little number line again. 1, 2, 3. -3 is 3 spaces from 0. So the absolute value of -3 is 3 because it's 3 spaces away, not -3. If you think about it, in math, distances are always positive. A negative distance only indicates a direction. So in this class, we never use a negative distance. Think about it this way. Let's say you're at your house and you go jogging. Hold on, let me get a little jogger here. Okay, and they're out jogging. And they jog a total of 3 miles. Okay, well, they need to finish their jog, so they jog back home. And they get there. Have they gone a total of 0 miles? No, that'd be ludicrous. That wouldn't make any sense. They went 3 miles this way, and then they went 3 miles back that way. So they went a total of 6 miles, right? I mean, otherwise, if I jog in a straight line for 3 miles, you know, I get all tired and sweaty and all that kind of stuff. Then I turn around and I jog back home the same exact path, same exact distance. No, like, do my clothes start to dry of perspiration? Do I feel refreshed and not tired? No, I get even sweatier and smellier and even more tired. All right, so keeping that friendly little number line in mind, that friendly little number line, where'd he go? Oh, there's another friendly little number line. All right, I'm going to ask you what you think the absolute value of x equals 7. What do you think x is? Now, I know some of you are yelling out, 7, 7. You're not correct. You're not correct. But some of you are taking your time to think. You're going, well, I know there's a 7 over here that is 7 spaces away from 0, right? 7 spaces. Absolutely. But there's a number over here that is also 7 spaces away from 0. Not -7 spaces away, it's 7 spaces away. So the solution to this would be x equals 7 or x equals -7. You may write it like this. Now be careful, it won't always be that simple. We will do some in a couple days that have some algebra involved. And they won't be so simple where you can just go, oh, it's the positive and the negative. And I guarantee some of you are going to say that and say, you said in the video. And we'll go back and replay the video, and I'll be right. All right, anyway. So, tell you what. Try these two problems. So x is going to equal 4. the absolute value of x is going to equal 10. Actually, we're going to do 4 problems because they're so simple. Absolute value of x is going to equal 0, and the absolute value of x will equal negative 3. Go ahead and pause the video, and we'll see if you come up with my answers. Okay, if you've unpaused the video, I can only assume you have all 4 problems done. If not, pause it again. My answer is going to pop up here. I know that on a number line, ooh, there's a number line. I know there are 2 numbers that are 4 units away from 0. So x must equal 4 or x must equal negative 4. This problem over here, the second one, absolute value of x equals 10, is a very similar problem. There's 2 numbers on that number line on opposite sides of 0 that are 10 units away. One is 10. The other one is negative 10. All right, coming down to the absolute value of x equals 0. This is a pretty easy one. How many numbers are 0 units away from 0? I can only think of one. And what is that one number? It's 0. Yeah. Now this one's a little bit trickier. Remember my jogging example where I had a little jogger. I wonder where he's off to. Maybe he's off exercising some more. Oh, there he is, right back at home. He's resting. He's being lazy. Let's bring him down here. I will give you $1 if you can make this jogger jog negative 3 miles. You know you can't do it. That's why I'm willing to give you money to do it. Mr. Lawrence has not made up money. So there is no number on a number line that is negative 3 units away from 0. This number over here is a negative 3, but if you count the spaces, 1, 2, 3, it's not negative 3 spaces. If you count backwards, it's still 1, 2, 3, 3 spaces. So there is no number. So this problem has no solution. I was trying to trick you. Okay, that is the beginning stages of absolute value. We'll get more into it later. Before we do that, we have to make sure we're good with this idea called compound inequality. All right, a compound inequality might look like this. It looks like 2 inequalities put together. 10 is less than 2x plus 4, which is less than 12. Now, some of you might look at this and go, I have no idea how to do it, but you actually do. I mean, think about it. Let's say the inequality, move please, it's not moving. Ah, it moved too far. Oh dear, we're having lag. Okay, let's say the inequality, go back. Let's say the inequality looked just like that. You'd know what to do. You'd use your steps. You get x alone, right? You subtract 4, and then you divide by 2. You'd know what to do, right? Okay. If the inequality looked like this, you'd know what to do. You'd use your questions. You'd say, well, what do I need to do to get x alone? There's a 2 attached by multiplication, a 4 by addition. All Saddam tells me to undo subtraction before I undo multiplication. Don't forget Saddam. He's a good friend of ours. Okay, so I'm going to go ahead. Alrighty, guys, I got interrupted there by Mr. Morgan. He needed to take care of something. He's done with his beatings now. Just kidding. So I can't remember the last thing I said. It's been about 20 minutes, half an hour since I've recorded. I think I was saying that you would subtract 4 from both sides and so that you know how to do this half of the problem, right? Well, if you know how to do this half of the problem and you know how to do the first half of the problem, then all you have to do is put the problem together and do it all. So I actually you might think about this as having an inequality with 3 sides to it as opposed to 2 sides, a left side, a middle side, and a right side. So I'm going to focus in on that middle. My goal is still to get the x alone, right? And I know that there's a 2 attached by multiplication and a 4 attached by addition. So what I'm going to do is Saddam is going to tell me to undo the addition before I undo the multiplication. So I'm going to subtract 4. But I'm going to do it in the middle. I'm going to do it on the right side, and I'm going to do it on the left side. And then when I do that, I just subtract. I'll get 6 is less than 2x, which is less than 8. Now, the x still isn't alone, so you know you have to divide by 2. And again, I'm going to do it in the middle. I'm going to do it on the left, and I'm going to do it on the right. And when I do that, I'm going to end up with, pardon me one second, and I need to scroll a little bit. Whoa, too far. Okay, I'm going to get 3 is less than x, which is less than 4. Now, putting that on a number line. All right. In this inequality, we have 2 important numbers. You know, in the other inequalities we were doing on Thursday, we only had 1 important number. And I said, that's the only one you have to show. Well, this one has 2 important numbers. It has a 3 and a 4. The point on the 3 is going to be open because there's no equal sign. The point on the 4 is going to be open. Now I need to pick a number that makes that true. And that's where I'll shade. I can test, you know, numbers less than 3. Like, let's take 0. I'll test 0. Let's see here. Let's see, 0. If I put 0 in, is 3 less than 0? No, it is not. That doesn't work. I won't shade toward the 0. Let's pick a number bigger than 4, say like 10. Is 3 less than 10? Well, it sure is. Is 10 less than 4? Nada. Not going to work. I'm not going to shade towards the 10. Sorry, my 10 didn't show up very well. But I will pick a number like, say, 3.5. Is 3 less than 3.5? It sure is. Is 3.5 less than 4? Ding, 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 we have a winner. So that means when I shade, I'm going to shade in between the 2 points. Ooh, I don't like that. That kind of makes it look like, well, here, let me do this. Maybe this will work. I'll just make that open circle bigger. All right, but it's the in between the 2 points that's the important part. And of course, the points are open. All right, now there's another type of inequality. You might have an inequality something like this, or you have where the compound inequality is actually broken up into 2 parts using the word or. You have 3x plus 1 is greater than 10, or 3x plus 1 is less than 0. If I were Allie Hart, I would say I'm going to solve these two independently of each other. I will do that, but then when I go to my number line, I'll put both graphs on the same number line. So let's watch and see how this works. First of all, I'm going to subtract 1 from both sides. I'll get 3x is greater than 9, and then I will divide by 3, and then x will be greater than 3. That is one part of the solution. Or I'll jump over here, and on this one I'm actually going to subtract 1 from each side. Okay, just like I did in the first one, I'll get 3x is less than negative 1, and then I'll have to divide by 3, giving me the inequality x is less than negative 1/3. So I have those two inequalities. Both of those have to fit onto my number line. So let me get a number line out here. Okay, and I have, let's see, 3 is an important number. It's an open circle. And where are the numbers where x is greater than 3? I mean, pick a number that makes that true, like 7. 7's over here. I'm going to shade towards the 7. Okay, I need to put negative 1/3 on my number line. It's an open point because there's no equals. And I need a number that makes that true. Give me a number that makes that true for x. Well, let's see. How about like a -5? Yeah, so I'm going to shade that way. There you go. All right, I'm going to give you 2 sample problems. You can test them. Go ahead and pause the video after I put them up, and then you can try them on your own. All right, hold on. Okay, there are your 2 sample problems. Go ahead and give them a shot. Make sure you do the number lines. And when you finish pausing, you'll see my work pop up. Okay, if you've finished pausing, you've done the work, restarted, here comes my work. I'm not saying much, but that's okay. You should be able to follow what I'm doing. My number line will look like this. -5, open circle, +7, open circle, and the numbers that make it true are all in between there. Okay, my solution for 2 will be done independently. I'll subtract 4 to begin with. When I do that, I will get 8 is greater than 3x. I'll divide by 3. So then I will get 2 2/3. Sorry, I'm getting very tired. It has been a long week. I'll come over here and do this part. I'll subtract 5 from each side. I'll get x is greater than 25. So my solution is 2 2/3 is greater than x, or x is greater than 25. When I head to a number line, it'll look like this. I'll put 2 2/3 on there, open circle, because it's not equal to 25, open circle. I'll start with this one. Where are the numbers greater than 25? Well, they're to the right of 25, right? And they're going to go forever. And over here, I need 2 2/3 to be greater than all the values of x. Well, all the numbers that 2 2/3 is greater than come this way. Let me see if I can back it up. There we go. And they go on forever in that direction. All right, very good. I guess that's it. Have a great weekend. Feel free to watch the video more than once, and we'll get some practice with this on Monday. Remember, there's going to be a quiz on solving equations. Mr. Lawrence signing off.